Hey, Libby, we're going through 3-3 homework problems. We're starting with 58. We're going to work backwards a little bit. I don't want to do all the problems, but we're going to start from the back and work to the front. This guy, the square root of cotangent, or inverse cotangent, let's write him as inverse cotangent to the -1 power. Can we do that? Or to the, excuse me, to the 1/2 power, not to the -1/2 power.
Yep.
1/2 power.
That's what I did.
Okay, then what do we do?
Ln.
Oh, I didn't even ln. You don't even have to ln.
Why?
I mean, you can if you want to.
To do?
You don't have to ln.
Can we? Since I did it.
What?
It can.
But that makes it ickier
I don't think
if you ln both sides.
No, because then you can bring the 1/2 down.
No, I just want to do the chain rule,
Ew.
right? Chain rule, 1/2 comes down in front. This guy, inverse cotangent of x, whoop, to the -1/2 power, and then what?
Times.
The derivative of this stuff. The derivative of the inside. Okay, what's the derivative of the inside?
You gotta have this one memorized. Come true.
What? I don't have this one memorized.
Memorized.
-1/1 plus u squared. What's u in this case?
U is x.
Just x, right? We don't have to do anything, and we don't have to do a du dx because he's just x, right? So -1/1 plus x squared. -1/1 plus x squared. That's what he is. Okay, let's put them together and make him nicer. I've got 3 pieces. This one, this one, this one. Let's put some stuff together and make him nicer. -1/. Let's multiply him here. Can we do that? 2 times that junk. What will that make? If I multiply that 2 through the bottom of the other on the right side.
2 plus 2x squared.
Yep, 2 plus 2x squared. Let's do that. Okay. And then this cotangent is now moved to the bottom because he's to the -1/2 power. When he's to the +1/2 power, he'll be square root, and he'll be just inverse cotangent. Oh, I keep putting parentheses. That work?
That's it.
That's it. We'll do that.
Okay,
Now, if you ln both sides, you probably got the same answer. You might just look a little different,
no,
but
I didn't.
well, but does he simplify to be the same?
I have
might-
negative square root of inverse cotangent of x over cotangent of negative or inverse. Gosh dang it! I don't know.
I bet you he is the same. If you did it right, I bet you he's the same.
Wait, I didn't get that actually. Which one is this? 58?
Average 4 hours and
Oh, I just didn't finish it, did I?
for the week. Last week was
Why is your race on the right?
Yeah, because you guys.
last week was
I don't know.
7 hours.
Well, he's wrong.
I don't know. He might be.
37.
He might. He might. I don't know.
Because
How am
I
I
don't-
gonna take a test when I don't even know how to do a homework problem?
You're fine. Okay.
You always say
Well,
that.
yeah, I know, but we're only like 3 sections in, so we're fine. Okay. That was 58. 50? Should we backtrack to 50?
No.
What?
Okay.
Not yet. Okay. That is him. 58.
Huh?
2 hours and
I think so, but I need to check. Sorry, I'm like not with it today.
Boys, are you done with the front ones?
I wrote it down.
Yeah, I know, but are you done with all the other ones?
Wait, can you stay there for a second?
You did not.
Okay, you best be getting going instead of doing what you're doing.
Yeah.
Okay, should we go to 50?
Yeah.
Yeah.
Well,
50. Somebody read it to me, would
I
you?
don't have it yet.
Does somebody have it?
For 50? Oh, I don't have my phone.
Y equals 1 over inverse tangent x.
Inverse tangent x. Oh, I love this one. I love this
That's
one.
easy.
Are you ready?
I don't even have work for it.
Yeah.
I do. Yeah, I do.
Yeah. Are you ready for this?
No.
Are you listening, Chase?
Yep.
Okay. Inverse tangent, the way it's written like that, this actually means the whole thing to the -1 power, right? Like that's what he is, right?
Yeah.
Okay. Because he's on the bottom, I could make him nicer by putting him back to the top, and guess what he becomes?
Just tangent x.
Just tangent x to the first power, right? Now we just take the derivative. What's the derivative of tangent x? Do you remember?
Nope.
Nope. Secant squared x.
How did I get that one wrong too?
dy dx. I bet you he reduces to secant squared x.
No, I got 1 plus x squared.
What? Wait, is that 50?
1 over 1
Looks like 3.
plus x squared times 1.
I don't know.
Go up to the top, the little equations. So I
This
did
one?
that, but on the bottom, and then I flipped it.
Oh, but the problem is you have to use, if you're going to do that approach, you have to use the quotient rule. So he would be like f prime g, g prime f, all over g
No.
squared, that stuff. Yuck.
What?
F prime g times g prime f, yeah. Yeah, if you're going to do that approach, you totally can, but you would have to do f prime g, g prime f. Yeah. I get that. Okay. But that's what I would do for 50, is I would just move him to the top. Should we go to 48? Somebody read it to me? We'll see how we can do for this one.
Will we have formulas for the test?
Uh-huh. You, like these, you mean?
Yeah.
These guys right here? Yes, I will give you those. Okay. 48.
Y equals secant.
Yeah. Yeah. Y equals what? Chase? 48?
Secant to the negative first.
Okay. X.
X to the fifth.
X to the fifth.
Yeah.
Like that?
Parentheses.
Is there parentheses in that? Yeah. Okay. Okay. All right. Okay. The rule for secant. I kind of keep like zooming in and out. The rule for inverse secant is, I'm going to do it up here. So inverse x to the fifth. This is what we're doing right here. And we got to do this guy. Okay. What in this case is u? X to the fifth. So I'm going to put x to the fifth here. I'm going to put x to the fifth here. And then I need, what's du dx?
The derivative.
The derivative of x to the fifth, which is 5x to the fourth. Yeah? Okay, so I'm going to fix him. I've got 1 over absolute value of x to the fifth. Square root of, what would that make?
To the 10th.
X to the 10th minus 1. And then times the 5x to the fourth on the outside. But I'm going to lump him onto the top. Can I go 5x to the fourth up here?
Yeah.
That's him.
Whoa.
How did that go? Does that make sense? Your u in this case is what you're taking the secant of. So you put that in place of all the u's, and then du dx is that 5x to the fourth, and then you just simplify. That's what his derivative is. Okay? How about that? Was that one okay?
That was okay. Is that the answer then?
Uh-huh. The one that is circled. Okay? All right. Should we keep trucking along? 46?
Mm-hmm.
Was that 46? That was, no,
That was
46. What's 46?
I don't remember.
46.
Y equals cosine to the negative first.
Of?
Cosine x in parentheses.
Ugh. Okay. Inverse cosine of x. Hey! Okay. We'll do this longhand way. What? Do what?
Nothing.
No, say what you're going to say.
All will be wrong.
No, say what you're going to say. I bet you're
So
right.
Do they cancel out?
They do. But let's do the longhand one and we'll see what we get. Okay. So inverse cosine is what we got right here. Okay. So we'll show you. I'll show you why they cancel out. Blah blah blah. Inverse cosine of cosine x. Okay. So that's what we have right here. So in this case, my u is my cosine x. Got it? Yeah. Okay. So this is negative 1 over the square root of 1 minus cosine x squared times du dx, which is, what's the derivative of cosine? Negative sine. Okay, so here's what we have. When we lump those two together, I have the negatives go away, become positive. I have sine of x over the square root of 1 minus cosine x, or cosine squared x. That's what we have, yeah? Okay. If you left it like that, that's totally right. Like, that is totally fine. Okay, but do you know what 1 minus cosine squared is?
No.
Well, you non-trig kids, you don't know this. But you trig kids should maybe do.
No.
1 minus cosine squared. What's sine squared plus cosine squared? I have a poster. What's sine squared plus cosine squared? 1. Okay, so if I lump the cosine over here to the other side, 1 minus cosine squared, x is
0.
no. 1 minus cosine squared x is equal to sine squared. Okay, so this guy is sine squared x, right? Okay, what's the square root of sine squared x? Sine x. What's sine x divided by sine x? 1. Okay, yeah?
So 1.
Now, if you would have gone down to this original guy and Chase said, do they cancel out? Does inverse cosine and regular cosine cancel out? Yes. So you're looking at just y equals x. What's the derivative of x?
1.
1. You see how that works? Yeah. Now, if you totally did it the other way, that's fine. And you left it like that. I mean, some of you guys don't know or remember that 1 minus cosine squared x is sine squared x, obviously. But, so that's fine. But that's what it simplifies to be. Okay. And I won't hold that against you. All right. Should we keep going?
Yeah.
Yeah.
Yeah. 38.
Mhm.
Give him to me. What do you got? Y equals.
Y equals, in parentheses, 2x to the second.
Like this?
No, it's all.
Okay.
2x squared. Minus 2x plus 1. Into parentheses, e to 2x.
E to the 2x?
Mm-hmm.
Perfect. Okay, what are we going to do?
Product rule?
We have to have a product rule. So I've got this junk here and this junk here. I have F and a G. Okay? F prime G plus G prime F. Okay, F prime. What's the derivative of the F part?
4x minus 2.
4x minus 2. Got it. Okay, G just stays e to the 2x plus. What's the derivative of e to the 2x?
Isn't it like e to the 2x times 2x?
E to the 2x times the derivative of 2x, which is just 2.
2 times.
Yep. And then I've got F, which is 2x squared minus 2x plus 1. Okay. Good. All right, let's simplify him just a little bit more. This part I'm going to leave. 4x minus 2, e to the 2x. This junk I'm going to put together, and I'm going to slap him on the front. So what does that make on the front of him?
What?
If I put these two together right here.
Oh, 4x squared minus 4x plus.
Perfect. We'll leave him like that. Okay? Because you can't put this piece together with that piece, so we're good. Okay?
Is that it?
That's it. That's all we're going to do for that one. You can't simplify it anymore.
Well,
Whoa.
those be basically,
The E guys kill you? It's just the same. The derivative of E to something is the same thing times the derivative of the exponent. Okay?
32.
32.
I did that one.
Okay, give it to me.
Y equals x to the sine x power.
X to the sine x power?
Yep.
Ugh, how are we going to do this?
Can you get that down?
How can you get him down?
ln.
You have to ln both sides before you can get him down. Yeah? Okay, so I've got ln y equals, I'm going to do sine x times ln x. So now what do we have to do?
Take the derivative.
Okay, what's the derivative of ln y?
1 over y dy dx.
1 over y dy dx. Okay. Equals. How do I do this? What's that?
Cosine.
No, but what are you doing?
What?
What do you got to do the derivative of this? Eli wants to say it. Product rule, right? He's
No.
multiply. Yeah. So f prime g plus g prime f. All right. What's the derivative of sine of x?
Cosine.
Cosine. Okay. And then g is just ln x. Okay. Plus what's g prime? What's the derivative of ln of x?
I don't remember. 1 over x.
1 over x. Okay. Times f, which is sine x. I don't know how we need to simplify him. I don't know. Dy dx. The y is going to go over to the other side, right? We're going to multiply by y. So y times cosine, I'll do this. Y times cosine x, ln x, plus, I'm going to go sine x over x. I don't know why I have a bracket there. Let's do that. And then what do we want? Do we want to plug y back in?
No.
No.
Dy dx equals y is x to the sine x power times that junk. Okay? How's that? Yuck. Disgusting. Okay? How many do we have left?
22.
Okay. I'm running out of room. Can I erase some of these? Yep. 22.
Y equals e to the x power over ln x.
Y equals e to the x power
Over ln x.
over ln x. Ugh. Okay, what shall we do? What do you want to do?
Is get down,
Can we get e down?
remove ln out.
I don't think we can. Let's do the quotient rule. Can we do the quotient rule? That would be the easiest. You could ln both sides, but then you'd have like ln of x at some point, and I don't want to do that. Let's do the quotient rule. F prime g minus g prime f all over g squared. Okay, what is f prime? What's the derivative of e to the x?
E to the x.
E to the x. Okay, g is just ln x. Minus, what's g prime? What's the derivative of ln of x?
1 over x.
1 over x. F is e to the x. All over g squared, which is ln of x, that whole thing, squared. So there's my derivative. Can we fancy him up a little bit?
Yeah.
I don't know. E to the x, ln x minus, I'm going to go e to the x over x, and then ln x squared. Just get rid of some of my parentheses. That's how I would leave him, maybe. I don't know. I don't know. What?
ln squared x, would that work?
No, it's not the same thing for sine. I don't think. I don't know. That's a good question. I don't know the answer to that. Like, do you write it as like ln squared x?
Yeah.
I don't know if I've ever seen it like that before. Maybe.
Ln squared
But isn't ln
times
not
x
numbers?
is like this.
No, ln's not a number. ln is like sine. It's like taking that operation of x. So it's kind of, yeah, I don't know why you couldn't. Yeah, ln squared x instead of like ln x squared, that thing. Yeah. It's just like with sine x though, like you don't want to write that as ln x squared because you want to take the ln of the x before you square it and not square the x before you take ln, you know? Whatever. Yeah, I don't know. Are you looking it up?
Yeah.
Okay. You tell me in a minute. All right. Moving on. Next, 20. We're going to end up doing all of these. I didn't want to. Okay. Whatever. It's fine. 22. Give it to me. 20. 20. Give it to me. What do you got?
Y equals sine of e to the x.
Sine of e to the x. Okay. Do you know what you do to find this derivative? How do you do this?
That's it.
What?
I don't know, I just put
Is it?
cosine of e to the x times e to the x.
That's right. But do you know what rule you used?
No, it's product. I don't know
Not
what
product.
that is.
Like e to the x is stuck inside of sine. So what rule is that?
No idea.
It's a
Yeah,
chain rule.
chain.
Yeah, it's a chain rule. Something stuck inside of something. So the outside function is sine of x. Let's take the derivative of that first. Sine of x is cosine. So cosine e to the x. That's my outside derivative. Now I take the derivative of the inside. What's the derivative of e to the x? Yeah, e to the x. So I'm going to lump him on the front. I'm going to say e to the x cosine of e to the x. So this e to the x is stuck inside. This one's on the outside. Weird. That's the derivative. What?
Like the ln squared x, you can do that.
Yeah, it is. Nice. Cool. I did not know that.
Yeah.
That's a good question. Uh-huh. Yep. All right. 18. What you got?
Y equals e to the 1 over x.
E to the 1 over x power? Oh. Okay, I'm going to write that as e to the x to the negative first power. That's kind of disgusting.
Do we have to write it like that?
Can't you just leave it like that?
Can we do the same thing
What?
as we just did?
What do you mean?
E to the 1 over x times negative x.
Yeah. Okay, back up. Don't listen to what I just said. Taking the derivative of e to the 1 over x is e to the 1 over x times the derivative of the exponent. So 1 over x, we just have to find his derivative, right? But that is the same thing as x to the minus 1. Okay, let's take the derivative. Negative 1, x to the
Wait.
negative 2 power. Okay, so what does that become if we move the x back down?
Negative 1 over x squared.
Negative 1 over x squared. So, final answer, I'm going to bump him up to the top. Negative e to the 1 over x all over x squared. Can I write it like that? Sure. You don't have to, but I'm going to. Yeah? We're just in sleepy land today. For sure.
More like I'm sad. I don't
You're
get it.
sad.
Y
You don't
equals
get it?
E
You're getting all these right. Except the last ones. Those are kind of hard.
equals e to the negative fifth x squared.
What?
X squared off that.
Like that?
Yeah.
Okay. All right. What's the derivative of that?
E to the negative 5 x squared.
Okay, he stays.
Times
E to the
negative
negative 5x squared. Yep. Times the derivative of the exponent. Negative 10x.
10x.
So if you want to write him like maybe better-ish, negative 10x e to the negative 5x squared. Boom. There he is. Good?
That was awful.
That was awful. Okay. Shall we go through and do some like whiteboard problems before we do related rates tomorrow?
Yeah, because I'm gonna like pass out.
Before we do related rates, which is tomorrow.
Before we what's tomorrow?
Related rates.
We just call it a year.
119.
Okay. Should I stay recording for this or no?
Bro, I mean
Yeah?
like the 70s.
Yeah, I'd say.
Stay recording? Okay, go get a whiteboard. Or if you want to grab a piece of paper so that you have these like later on, that wouldn't be a bad idea either. So you can like look back at this.
The recording of the whiteboard stuff, and then I'll just watch that because I'm scared I'm gonna fall asleep. And
Sure.
Take a nap.
But try. Try for now. And I'll send it to you also in case you fall asleep. Okay? Alright, so grab a piece of paper or a whiteboard. I don't care what you do. Boys, let's get rolling. Okay. Let's go way back to ln land. And here we go. ln of x. What's the derivative of ln of x?
1 over x.
1 over x. Okay, so we're reviewing. Ready? Let's go the derivative of ln of, let's say, I don't know, x squared plus 4x. Okay? Boys, are you watching?
Yep.
All right. The derivative of ln of x is 1 over x. That's what he becomes.
Uh-huh.
What about ln of x squared plus 4x?
Do you have to take the derivative of x squared?
You will eventually, but you do 1 over that junk
X
first
squared plus 4x.
times
Times the derivative.
So 1 over x.
2x plus 4.
2x.
Okay, so a lot of times we'll just lump him on the top and we'll say 2x plus 4 over x squared plus 4x. Perfect. There he is. Okay. All right, one more. Let's do ln of x cubed plus 7x minus 3. What is his derivative? Write him down. See what you get. Yep. All right, what'd you get?
3x squared.
3x squared plus 7
over all of that.
over all that junk, right?
Are we getting what we're gonna do on our
Yes. Yep. We're just reviewing ln for like 2 seconds and then we're moving on. Okay, good for ln's? Okay, now let's go to do some e's. Okay, so here's e. If I just have e to the x, what's the derivative? E to the x. Okay, all right, let's do e to the x squared plus 4x. How do I do that? If you're taking the derivative of e to that stuff. Chase, put your phone away. If you're taking the derivative of e to that stuff. Mm-mm. He stays. E to the x squared plus 4x. He stays that. Right? The derivative of e to the something is e to that something, but then we take times the derivative of the inside, 2x plus 4, right? Now, we technically did that over here, right? The derivative of e to the x is e to the x times the derivative of the exponent. What's the derivative of x? 1, right? We technically did it over there. But e to the exponent times the derivative of the exponent, okay? All right, do this one. E to the x cubed plus 7x minus 3. Do that one. Okay, you should get e to the x cubed plus 7x minus 3 times the derivative of the exponent. I'm going to put him in the front. Can I do that?
3x squared plus 7.
3x squared plus 7, yeah? There you go. That's it. Okay? Good? All right, let's do something like this. Let's do, this one's a little bit harder. Let's do like x to the 4th power times e to the 2x power. How do you do the derivative of that? How would you do the derivative of that? Let's get it started. What do you have to do there?
Product rule.
Product rule. Okay, can you do the product rule with these guys? You try it and see what you get. There's F and there's G. Do the product rule. Go.
What's the derivative
just leave it like that and I'll simplify.
Yeah, I wouldn't simplify too much.
No.
I don't know how to simplify.
Gosh dang it.
Mm. Mm. Did you get something like this? 4x cubed e to the 2x plus 2x to the fourth e to the 2x. Is that what you got? Yeah? Something of that nature?
Wait.
Yeah?
Where did I get a 4?
Where did you get a what?
I got another 4 somewhere.
And your second piece?
Yeah.
Can you look at it?
Oh, I did.
Oh. Yeah, you use the derivative again there.
Oh, and I just left it the wrong.
Yep. Okay, good. Happy with that? That's E stuff. Should we do some more of those E's or should we move on to the inverse trig function stuff? Inverse. Okay, so let's do, okay, so you're going to need your note sheet. You have your note sheet that has the inverse function list. Ugh, I got to go up here. This guy. Okay, that's what you want. I'm going to erase all my stuff. Okay, here's what I want. I am going to do inverse sine of x to the 4th power. Let's do that. Inverse sine of x to the 4th power. Do that derivative. You're looking at this guy right here. Okay, there's your rule. Just figure out where the u's and all that junk goes. Okay, inverse sine of x to the 4th power. Get him gone.
I don't remember how to start this.
Just follow the formula. Figure out what u is.
Is U?
U is X.
X to the 4th.
Yeah.
Right? U is whatever you're taking the derivative of.
So is that then 4x to the 6th? Or
What?
4x to the 5th.
X to the fourth.
So when you plug him into here, he will be x to the 8th power, right? X to the 4th squared. Then when you take du, then when you do du dx, what's the derivative of x to the 4th?
8x to the 6th.
Nope. 4x cubed.
Uh,
You see that? Okay, so final answer. 1 over this, not the final answer. 1 minus x to the 8th times 4x cubed. Then I'm going to lump him onto the top. So 4x cubed over square root 1 minus x to the 8th. Okay, good? Yeah? All right, let's do some more. Let's do cosecant. Inverse cosecant of, let's go 2x cubed. This one's going to kind of be icky, maybe. Inverse cosecant. Here he is, right here. There's the rule. Follow him.
Can you zoom out a little bit?
All right. Do we follow the formula? What's u?
2x
2x cubed. Whoop. So he's going to go right here. 2x cubed and 2x cubed. And then what's du dx going to be? 6x squared. Okay, I'm going to lump the 6x squared onto the top. So I'm going to get negative out in front of everything. 6x squared, or you can put the negative at the top. It doesn't matter. absolute value of 2x cubed.
Mm-hmm.
Okay, then be careful because you have to square the 2 and the cube, right? So this would be actually 4x to the 6th power minus 1. Do you see that? This is your derivative. Okay, now let's say I want to know the derivative at x equals 1. Could you do that? If I say I want to know the exact derivative, or I want to know the slope of the tangent line at x equals 1.
Yeah.
Yeah, you just plug 1 in, right? I don't want you to do that because it might come out really nasty. I bet you it does. Okay, so don't do that for now. Okay, good. Should we do some more of those?
Whoa.
What? Well, what? What else do I need to do? What was the hard ones?
I don't know.
All of it.
Grayed out.
They were all hard? They were not all hard. You just did a whole bunch. But there's some that had like a chain inside of a, I don't remember what it was. Oh, let's do one of those. Let's do inverse sine of x to the 5th power. Let's do that. Inverse sine of x to the 5th power. That junk. All of that to the 5th power. Do you know how to do that?
No.
Okay, what shall we do?
5 sine.
This is the chain rule. We've got to bring the 5 down in front. Okay, so 5, everything in the middle stays the same. Now he is to the 4th power times the derivative of the inside. Okay, what's the derivative of sine? Whatever this junk is. Or inverse sine, that's what I mean. Inverse sine. 1 over the square root of, what's u in my case? Just x, right? It's just x. 1 over the square root of 1 minus x squared. That's it. I guess you could lump him on the top if you want to do 5. Inverse sine of x to the 4th power all over the square root of that junk. If you want to write it like that, you can. Okay.
Give us another one of those.
Another one of those?
Make us do those.
Okay. Let's have you do the cosine, inverse cosine of x. Let's do this. Let's do 3x. Can I make it hard?
Yep.
3x all to the 7th power. Okay, try that. See how you do.
Oh boy.
Okay, the cosine rule is, here's the rule for cosine. I'll write it down here. Negative 1 over the square root of 1 minus u squared du dx. That's the rule for cosine. Okay, inverse cosine. Go back to what? What? Up. I just wrote it down for you. This is cosine. This is the rule for cosine. Okay? All right. Then you did it right?
Okay, go ahead.
Okay, so chain rule 7, leave the middle, inverse cosine 3x to the 6th power now times the derivative of the inside, which is negative 1 over the square root of 1 minus, what's u?
9x squared.
Yeah, this will be 9x squared if you FOIL it out, times the derivative of the inside. What's the derivative of the inside? 3. So I'm going to put the 3 on the top.
So negative 21.
Yep, negative 21 inverse cosine 3x, this junk, if you want to write it like this, all over the square root of 1 minus 9x squared. Hey, look at you. See? You're doing fine.
No, I just got lucky on my own.
You what? You got lucky. That's a lot of getting lucky right there with all those x's and y's and whatever else. Okay, all right, we'll be done. Tomorrow we'll start related rates. You will love and hate them.